We're here with Magdalena today. I'm very excited to talk with you. Maybe you could give us a little background of yourself, and then we can talk about your career path, your submission to the hackathon last year, and more.
That sounds fantastic. Thank you so much for the invitation. I'm super excited to be here. So, I am Magdalena. I am a chemist by training and have left chemistry for some time. It pretty much started during high school, where I participated in an international competition called the International Chemistry Olympiad, which is essentially a long hackathon where you get to geek out about a topic with very many like-minded international people and also really get to hone in on chemistry itself. And after that, I moved to ETH Zurich for both my undergrad and master's in chemistry with the intention of becoming a synthetic applied chemist. And what I ended up doing was discovering the incredibly exciting topic of data-driven methods and machine learning applied to chemistry. That was around early 2022, so just before ChatGPT got launched. I've been fortunate to work on many exciting projects in the field where I moved both to ETH Zurich, EPFL, and MIT in 2024, so a bit over a year ago. I participated in the second LLM Hackathon for applications in material science and chemistry, and it's been incredibly exciting to work with the team there and continue on that journey.
So it sounded like you got interested in chemistry from the Olympiad. What got you interested in language models in particular?
I would say the exciting possibilities of what you can achieve with them that were previously also not really discovered, right? With the onset of transformers, which was in 2017. So actually quite recently, where you could accelerate so much in terms of translation of natural language and translating that to chemistry has been incredibly exciting and baffling to me. And essentially, generally, we've got so many advances in algorithms, natural language processing particularly, where in computer science, where we can get inspired in chemistry to answer questions that are not solvable by traditional means. For
Yeah.
instance, we have such a large amount of data in scientific literature, which is to some extent parsable, but not really just on the basis of rule-based systems. So they're natural language models, such as large language models, are an incredibly impactful tool to help us accelerate this process, essentially making processes that are very tedious as of now, if not even intractable, and enabling us to solve problems in chemistry with that. And natural language it's the way that we as humans communicate.
Yeah.
Also, to some extent in chemistry, smile strings are a notation we use in order to understand reactions to some extent because we abstract them to graphs and molecules. So it's the way how we communicate as chemists to some extent. And that's just what fascinates me, how we can get inspired by a different science and apply it to problems that are of interest to us.
Yeah, I think we all had sort of an aha moment at some point in our career. And for me, there have been a few. One was just when previous to Transformers, I had worked to extract various properties from the literature for polymer properties. And then it turned out that with the advent of GPT-3 especially, and 4, actually 4 especially, it was just like you could give the document to the model, give it a nice schema that you'd expect, and you'd get back what you, as a human, would expect to have in that schema, which was sort of stunning at the moment. And now we sort of take it for granted. But that was one of the moments when I started thinking about what we could do with these applications. And GPT-4 was actually announced the day that the first hackathon was held. So it's kind of an interesting coincidence that the people at the first hackathon had access to that. I did want to ask you a question about Switzerland in particular. What is the secret sauce to how Switzerland, in particular EPFL, has done so well in LLMs for chemistry and materials?
Well, the Swiss ecosystem specifically has a large focus on technical innovation, right? We've got fantastic resources here, so that just as a sort of a fruitful breeding ground for fantastic science to happen. And in terms of the research that's happening in terms of large language models, there are fantastic research groups such as those from Philipp Schwaller at EPFL that really hone in on LLM agents and focus on that for applications in chemistry. So it's really a matter of, as you said, it was announced the day of, potentially people even used GPT-4 on that very
Hmm.
day it got released. It's really about acting quickly and making use of the resources as they come available. And there's really been such a remarkable advance of the capabilities of LLMs, even looking at GPT-3, GPT 3.5, GPT-4, now GPT-5.
Hmm.
Certainly not exponential, but I have worked with LLMs professionally a year ago and now as well a year later. And it's always remarkable to see the capabilities, and it's also remarkable to see where LLMs sometimes still fail. Something that is also very important to us chemists working in the field is having a strong software engineering background. By that, I don't
Hmm.
mean necessarily being a computer scientist and understanding everything about the computer hardware, because that is, that's another field of study, but really applying hands-on skills to quickly and sustainably prototype. So during my time at EPFL, I definitely learned so much about that, about building sustainable, scalable Python packages that call LLMs, call tools for LLM agents, but also for any application in chemistry. And and this sort of notion of building a Python package and doing clean software engineering with a very modular structure, tests, etc. That's something that's very intimidating to
Hmm.
chemists who maybe had a Python course or, in our case, a C++ course in the first year of our studies, to now think about object-oriented programming, etc. It's something that's very intimidating, but it is so useful once you know how to use it and once you know how to build good software. And I
Hmm.
think that's also part of the secret sauce of leading research groups, that they students learn how to quickly and sustainably prototype new programs
Yeah.
and get results quickly in a sense, but also being able to verify and iterate over loads of different configurations, building reproducible software. That's It's just such a joyful moment for me to see a great paper, then look at the code on GitHub and being able to reproduce the results.
And that kind of leads us into the next topic of last year, you and your team had a prize winning entry for the hackathon called GlossaGen. Maybe you can tell us a little bit about the team, your thought process, what the application does. If you have a demo, that would be awesome. And, talk a little bit about some of the things that are not only computer science. So like, how is team important? How is it important to get the pitch right? What are the types of things that matter in a hackathon?
100%. So the way it worked last year was that I was interested in participating in the hackathon anyways. Something that I wanted to do and something that I think is a great thing to do is not necessarily teaming up with people you know. So what happened for me was that Dieter Plessers, my future teammate, sent me a Slack message after I introduced myself in the teaming Slack and said, "Oh yeah, I'm a chemist. I've been working on zeolites a lot. I had this idea, namely generating some sort of a glossary for scientific publications in order to understand them better." And I don't know what happened, but something clicked in my head there, and I was incredibly excited about this project. So we haven't known each other before that. We had some quick calls over the days, but even despite the fact that it was a remote team up, we were able to work really effectively on building a product slash proof of concept that takes a corpus of scientific literature, so maybe zeolite related papers that you need in order to write a review or a grant application, for instance, and then feeding it into an LLM pipeline that pinpoints specific terms in the text. So it parses the entire text and then extracts complicated or subject specific terms, so a glossary, as well as explanations for that. And we built this pipeline, we built an app for it. I'm super happy to show a quick demo. Let's hope it works still after a year.
We've all read papers where there are very complex terms in there that you haven't known before, and it's really nice to have a glossary or autogen a glossary for your paper. That's something that I should think about doing for some of my papers in the future.
That's fantastic to hear. And that's maybe also the first point to get started in terms of a successful hackathon participation, namely thinking of an idea that excites you and that
Hmm.
intrigues you, both in terms of the application in chemistry slash materials, but also in terms of what you want to learn. So for Dieter, it was a lot about learning LLMs and probing their capabilities in Zeolite specifically. For me, it was a lot about learning how to quickly prototype this whole application and make use of the skills I learned at EPFL, combining them in a project that excited us. And you get very creative, especially with the pitch. And I'd love to get back to that later. For now, let's look at a demo. Okay, so here we can see the graphical user interface that we built for GlossaGen, which we also used for the live demo. So you can see we took our time in customizing and branding GlossaGen. So here we have the IBM font and the Gradio app. And what you can essentially do there is take any random document and upload it. Right now, this is a random document from the Chem archive on imine-based natural complexes, and you can see that in a matter of seconds, it parsed the text here and generated a glossary where you can see interesting / more complicated terms being explained here. And of course, it's hard to do in less than 2 days, and also one of the largest challenges in LLM research, namely the evaluation and assessing the outputs. But with the help of our domain expert, Dieter, we were able to assess that the vast majority of the terms here using GPT-4 were in fact really useful and feasible. So this was the app that we built. And you can also see that we have a knowledge graph generation panel here as well, which I won't show now, but essentially the goal here was to then take the glossary and the paper, connect the nodes, and then show relationships in between the terms. So for example, for a Zeolite paper, we have a node, which is, for example, the synthesis method and then the individual components, etc., that are mentioned. So this has been really excited to build and sort of showcase a proof of concept for GlossaGen.
Yeah, that's great. It seems like it could be really helpful for many different applications. I'm thinking of connecting thoughts across papers would be a really interesting topic that this could address. If I'm interested in, for example, self-sorting, then I've run all these papers through this, then I can start finding kind of a defined vocabulary with papers that match self-sorting. So that could be quite interesting. In a hackathon, obviously there's like this short amount of time. There's also teaming aspects. What did you guys find helpful about your pitching? Like what helped you communicate this to the judges and such?
Yeah, fantastic point. And this is in fact one of the most important parts of a hackathon or of building such a product really quickly is that you showcase the idea, the motivation behind it in a very short and crisp pitch that ideally also contains a live demo to showcase the coding you've done. As I said, I've been very fortunate to have two fantastic teammates with both Dieter and Philippe. And our idea was to take it with humor, because humor is such a universal, joyful property of every human being. And we were imagining if there are so many people looking at these submissions, we want to showcase, okay, this is a product we're really excited about, but we also take it with a bit of humor. So you can watch our 2-minute video there, but essentially we had a hook of, okay, where can we use this? The scenario is we are just about to submit a large review or grant proposal where we need such a glossary. And the lead of the project is just writing, Dieter, can you finish this in by tonight? Actually, Dieter needs several days to curate such a large list. And maybe Magdalena had an idea to, oh, you can just use this app and then it's much quicker. And then you have essentially a holiday instead of working through the weekend. So that's, a bit of a jokey hook we used. You can have multiple ways to go about this, but we had like a quick WhatsApp chat to showcase this and then diving right into the specific use case. And this is really important to show how we can use this because there are so many applications of LLMs in chemistry nowadays, and it's important to showcase and filter out, okay, why do we actually need GlossaGen and how can we use it? Then really briefly, more high level than you would like because you've worked on it for several days, outline the pipeline, really not being too technical about it because for that you have the code base, and then showcasing the live demo. And it doesn't always go 100% smoothly. Typically, we use Gradio and QuickTime Player on Mac to record the screen. Of course, it can also be cut, and you can also show some pre-prepared examples, right? But the goal really is to showcase, okay, what does our software do? And I would say this was our secret sauce of sorts, that we were taking it with humor. We were really excited about our projects, and we built a proof of concept that I even thought of using that for a study guide for my
Mm-hmm.
own exams, and even building a LaTeX library. Unfortunately, the time did not suffice for that, and then other exams happened. But we had the impression that it was really useful and fun for a hackathon project. And it's not always the case that a startup, unicorn startup, is coming out of such a hackathon. It might very well be. I'm very excited to see the future and the progression
Mm-hmm.
of this hackathon. But for us, it was a fun project where we could really harness the interdisciplinarity of the field, namely chemistry, materials, and software engineering.
Yeah, that's great. I think, it really stood out to the judges as something unique, but also something well put together. Like you could obviously tell that like you thought about the interface, you thought about the way you were presenting the visuals, and you had this graph output, which was really nice. You kind of see that like the connections were being made between the terms. I thought that was really good. So I think you also had something to discuss around templates that could be useful for participants. And this is, not only hackathon participants, but if you're trying to prototype something very quickly with your team, something like this might be quite useful. So I'll let you take it away.
100%. So, yes, as I said, I'm a chemist by training. And as I said, I'm really fascinated by this aspect of sustainable prototyping, namely being able to really quickly realize your vision, which is very easy nowadays with LLMs, but still requires some structure, some external structure and cookie cutter. That's a term that you typically use in software engineering in order to fit your ideas into a pipeline that works for demos, that works for showcasing and building LLM chatbots. And this is something that hopefully it takes away a lot of the pain and the initial activation energy to get started. So I'm thinking of a chemist or material scientist who is really intrigued to get into the field and get contributing with their ideas, and now wants to, have not have too much trouble installing dependencies, etc. So I built a little open source template that everyone is very free to use. I'm also happy to showcase how it works and how you can get it to run, but it's essentially a bare bones implementation of really using this template, then installing dependencies, having a quick README, which is essentially the documentation to use in order for others to understand how to use the software, as well as some bare bones code you can change, a Gradio app, as I showed before with
Mm-hmm.
GlossaGen, that you can customize. This is actually the most fun part of the entire project, customizing the interface. So I hope to be able to enable many to use it and get prototyping with it. So once you download the template from GitHub, you can select a custom name for the repository, which reflects your project's name. It will essentially have the same structure. And as I said, it's a very bare bones template. So what you can do is look at the core structure. We use UV here, which is a dependency manager that is very quick and robust. You are also very free to use Python on its own, but we've got some installation instructions here. Essentially, what you need to do is customize to your own project name, then install dependencies, which are essentially the packages you need in order to operate. For instance, you might want to import OpenAI if you're using OpenAI LLMs, or Seaborn if you want to plot something, as well as Gemini, etc. So this is how you add them and how you install them, as well as all functions you have within your package. And then you've got some API keys that I highly recommend to always keep secret. So this is kept in this .env file, and you essentially have to copy it and enter your own API key from your provider. This is the pyproject.toml, which essentially lists all of the dependencies as well as a short description. It's like a recipe to tell Python what to install. And then you can run a very bare bones user interface that calls the source code, which is essentially the Gradio app, which you can customize with custom boxes, custom upload functions, etc., like I showed with GlossaGen before, as well as an LLM client you can call. So that in this case is calling Gemini 2.5 Flashlight. There are several other providers that you can use. So without further ado, let's try to get the code running. First, I'm installing all of the dependencies that are important to this project, and then I'm installing the project dependencies themselves. That should be pretty quick. Next off, let's copy the API keys, which I have stored here, and then we can run the main app, which essentially calls this script here that builds the Gradio app and integrates the LLM functionality as well. Then we should get the window to our own browser tab right here, and then you should be able to showcase your very first or your very own LLM demo. So this is really bare bones. You can customize everything here, and I would highly recommend you to do so. And right now we can enter any chatbot prompt. This is right now pretty much Gemini, but on a different interface. Ben, do you maybe have something you'd like to ask Gemini 2.5?
What would be a good application to build for making progress in materials science and chemistry? We'll give it real general stuff here.
Answer in a blade. That's just something I want to try. Okay, and then we get a response.
Nice.
And what you can do is essentially customize which modules are called in between, the way that the model is prompted, the way that the output is transformed, any visual multimodal capabilities. There's so much you can do, and I hope that people can get started from this repository. Of course, this is not a must. There have been many successful projects that used Google Colab, for instance, so not a must at all to use it. However, I believe that this quick prototyping enables us to do better teamwork and to also learn a lot about the software engineering aspect as well as chemistry we can infuse into these applications. So this is essentially GlossaGen V0.
This is great. Yeah, so with this you have the skeleton for all of the installation for your project, your initial Gradio app, and also your integration with an LLM provider. So you can swap those out for Google, or this is Google. You could swap it out for OpenAI or any of the other providers. And yeah, this is providing just a really nice thing to build upon, right? So obviously almost everything is sort of a prompt response. And so you can build upon that and hopefully get started a lot quicker. So thank you so much for that. That's great.
Glad to hear that.
Great. So thanks for showing that demo. So I guess, just a parting thought, what's next for you?
Yeah, I will stick around in the field. I'm still very, very excited about applying machine learning methods of various kinds to relevant problems in chemistry and chemical engineering. So the next immediate step for me, after having worked at a startup in Telpik for a few months, is starting my PhD in chemical engineering and computer science at MIT. So I kind of switched to the dark side of engineering and software engineering, but in my heart, I'm still a chemistry Olympian, and I'm very excited for the future of the field.
That's great. Thank you so much for being with us, and thanks for the template. Thanks for walking us through GlossaGen, and good luck at MIT.
Thank you so much, Ben. It's been a pleasure.